Hi everyone, today we're going to study volume of solids of revolution about x-axis. Let y equals f of x be the given curve. The volume V generated by the revolution of the curve y equals f of x about x-axis between x equals a and x equals b is, the formula is here. V equals the definite integral from a to b, pi y squared dx. This is example 1. Find the volume of the solid of revolution bounded by the curve y equals the square root of the quantity x plus 6 and the lines x equals 2 and x equals 5 about the x-axis. Let us write the formula here. Then let us substitute the corresponding values. So the v equals the definite integral from 2 to 5. We copy the pi down here, and the value of y here is the right-hand side of the equation of the curve. So we write here the square root of the quantity x plus 6, and then this is raised to 2. We copy the dx. Simplifying further, we can cancel the radical and the power 2. Also, this pi here is a constant that we can move outside the integral sign. So we have now v equals pi times the definite integral from 2 to 5 of the quantity x plus 6 dx. Now let us integrate. We copy the constant pi, so the x becomes x squared over 2 plus the 6 becomes 6x. We will evaluate by the limits of integration from 2 to 5. Evaluating now, we have pi times the quantity 5 squared over 2 plus 6 times 5 minus the second group, pi times the quantity 2 squared over 2 plus 6 times 2. Simplifying further, the first group becomes pi times the quantity 25 over 2 plus 30 minus the second group, pi times the quantity 2 plus 12. The first group can be simplified into pi times 42.5 minus the simplified second group is pi times 14. Getting the difference, we will get 26.5 pi. We write cubic units. This is the volume. This is the final answer. Example 2. Find the volume of the solid of revolution bounded by the circle x squared plus y squared equals 25 and the lines x equals 0 and x equals 3 about the x-axis. First, let us express the curve showing y as a function of x. Here is the equation of the curve. So we have now y equals the square root of the quantity 25 minus x squared. Now let us solve for the volume. We write the equation here. Substituting the corresponding values, we have now v equals the definite integral from 0 to 3, pi times the quantity, the square root of the quantity 25 minus x squared. And this is now raised to power 2. Then dx. We can cancel the radical and the power 2. Also, we can move this pi, being a constant, outside the integral sign. So we have now v equals pi times the integral from 0 to 3, 25 minus x squared dx. We will do integration now. We will copy the pi here, and the 25 becomes 25x minus the x squared becomes x cubed over 3, to be evaluated with the limits of integration from 0 to 3. So we have now pi times the quantity 25 times 3 minus 3 cubed over 3 minus the second group pi times the quantity 25 times 0 minus 0 cubed over 3. The second group here can be simplified into 0, so we can cancel this out. Let us simplify the first group. So we have now this 25 times 3 is 75 minus 3 cubed over 3 is 9. Simplifying further, this is 66. So we write 66 pi cubic units. This is the volume. This is the final answer. I hope you learned something from this video. See you again next time.